In 1961, railroad executives stared at the new EMD GP30 and called it the ugliest locomotive they had ever seen. Some even refused to order it, fearing the boxy, high-hood brute would ruin their carefully crafted images. But that ugly design hid innovations that secretly rewrote the rules of American railroading, and it laid the blueprint for almost every freight engine that followed. How did a locomotive so widely rejected for its looks overturn decades of tradition? And why did those same railroads come scrambling back in just months? The answer begins with a visual shock that no one saw coming. Streamlining was more than a design choice in mid-century America. It was the language of progress. After World War II, the railroads competed fiercely for passengers and for prestige, and nothing said modern like a locomotive with smooth, flowing lines. The marketing departments at companies like the New York Central and the Pennsylvania Railroad poured money into polished brochures and gleaming publicity photos. Their icons, the EMDF units and the Alco PAs, wore sweeping noses and chrome trim, echoing the optimism of jet-age cars and appliances. In the 1940s and the 1950s, the public face of railroading was long, low, and aerodynamic, whether it was pulling a streamliner across the plains or a commuter run into the city. This obsession with appearance was not just about catching the public's eye. Streamlined designs became a corporate signature, a symbol of reliability and speed. Railroads spent millions repainting and rebranding their fleets, convinced that a train's silhouette could shape its reputation as much as its schedule. Even as diesel engines replaced steam, the belief held strong. A locomotive should look as advanced as it performs. The rounded hoods and stainless steel fluting of the era's most famous trains were as much advertising as engineering, promising the future with every mile. By the late 1950s, though, the glamour was starting to fade. The rush of passengers was slowing, and freight was taking center stage. Yet the old rules about beauty lingered. New models like the EMD GP7 and GP9 still carried the softened curves and subtle contours that had defined the railroad's golden age. Even the utilitarian road switchers, designed for both yard work and mainline runs, tried to look the part. With clean lines and modest proportions, nothing too abrupt. For railroad executives, anything less was unthinkable. The idea that a locomotive might trade elegance for utility, that function might dictate form, seemed almost heretical. That is why, when the first GP30 rolled out in 1961, its sharp angles and abrupt rooflines landed like a thunderclap. The visual break from decades of streamlining was impossible to ignore. In a world where image had always been king, the arrival of something so unapologetically different would challenge every assumption about what a locomotive could or should be. The GP30 did not try to blend in. Its profile was all sharp edges and sudden transitions, a jarring departure from the long, low curves that had dominated American railroads for 2 decades. The first thing that caught the eye was the stepped cab roof, rising abruptly behind the windshield and then dropping again in a blocky sequence that trade magazines quickly labeled the humpback. The effect was unmistakable. A locomotive that looked like it was wearing a hard hat, bracing for heavy work rather than gliding through the landscape. Below the roofline, the body was a study in angularity. Flat, squared-off panels replaced the old rounded contours. The walkway on the engineer's side jutted out, lifted several inches above the frame to clear new pipes and conduits. On the fireman's side, a large duct ran the length of the hood, feeding cool air to the traction motors. Every surface seemed to have a purpose, but none of it was subtle. Then there was the radiator bulge, a broad, flared blister that rose from the rear of the long hood, stretching forward like a muscular shoulder. This feature, designed to accommodate larger radiators for the new turbocharged engine, broke up the silhouette even further. The bulge was so prominent that rail fans and critics alike debated whether it was an eyesore or a badge of power. Some called it the locomotive's hunchback. Others described it as a factory on wheels, stripped of any pretense of elegance. Trade press coverage at the time did not hold back. Trains magazine, in a 1962 review, described the GP30's appearance as unapologetically industrial, a machine that seemed to announce its function before it ever turned a wheel. Railroad executives, used to selling their trains as symbols of progress and style, were unsettled. The GP30's look was not just a break from tradition, it was a challenge to it. An open question about what mattered more, how a locomotive looked, or what it could do. EMD's design team, drawing on automotive influences from Detroit, had deliberately left behind the last traces of streamlining. Instead, every angle, every protrusion, every panel was there because it had to be. The result was a locomotive that stood apart from anything else on the rails, for better or worse. In an industry where image had always been king, the GP30's debut forced everyone to reconsider the value of appearances. Packing 2,250 horsepower into the GP30's familiar frame was nothing short of an engineering feat. EMD's designers started with the proven GP20 chassis, but their goal was to leapfrog the competition by squeezing more power out of the same length and wheelbase. At the heart of this push was the new 16-cylinder 560-Vendiden D3A engine, a turbocharged evolution of EMD's legendary 567 series. This prime mover delivered a full 250 horsepower more than the GP20, all without stretching the locomotive an inch longer. The challenge was not just about fitting a bigger engine. Turbocharging meant higher internal pressures, more heat, and greater demands on every system packed inside the car body. The GP30's frame, unchanged from its predecessor, had to absorb not only the extra weight but also the increased stress from its more powerful drivetrain. EMD's engineers responded with a series of clever adaptations. The turbocharger sat high in the hood, directly above the engine, while the electrical cabinet and air intake were stacked tightly into the same space. This vertical arrangement allowed the locomotive to keep its 4-axle, 56-foot 2-inch wheelbase, which was critical for navigating the tight curves and varied track work of American railroads. The new power plant did not just offer brute strength, it brought smoother acceleration, steadier speed on grades, and better fuel efficiency at higher loads. The turbo system scavenged exhaust gases, spinning up to force more air and thus more fuel into the cylinders. This produced a sharper throttle response and kept horsepower consistent, even at high altitudes or under heavy tonnage. For railroads, the result was a locomotive that could pull longer trains, climb steeper hills, and do it all with fewer units in the consist. This was a clear win for efficiency, but all that power created new headaches for heat management. The next problem EMD needed to solve was how to keep the turbocharged engine cool inside a body that had not grown any larger. That puzzle would shape the GP30's most distinctive feature and its most controversial design choice. Heat was the silent adversary inside every GP30. Pushing 2,250 horsepower through the compact frame meant the engine ran hotter than anything EMD had built before. That's why the rear of the long hood swelled outward into a broad, unmistakable blister. This wasn't a designer's flourish. The bulge made room for a new array of radiators grouped together at the back instead of split along the sides. These oversized cooling fans, two large ones flanking a smaller center unit, worked together to draw air through the entire system, keeping the turbocharged 567 D3A engine from cooking itself under load. The high short hood at the front wasn't just for show either. It concealed a much larger electrical cabinet and a central air intake, both stacked vertically to fit the tight space above the prime mover. By moving these components up and forward, EMD's engineers cleared the way for the massive radiators at the rear and simplified the routing of cables and ducts. The result was a hood that looked blocky and abrupt, but every inch of it had a job to do. Maintenance was another problem solved by the GP30's new form. Earlier locomotives forced shop crews to crawl through cramped passageways and wrestle with bolted-down panels. The GP30 introduced walk-in side doors and removable panels along the hood, giving mechanics direct access to key systems. A shop foreman from Illinois Railway Museum recalls, "You could get to the generator, the electrical cabinet, even the turbo without tearing half the thing apart. It cut our turnaround time in half." Every sharp angle and raised walkway had a purpose. The left side's elevated platform gave room for pipes and wiring, while the right side's duct channeled cool air straight to the traction motors. These details, invisible to the untrained eye, meant the GP30 could run harder, longer, and with less time spent in the shop. What looked harsh on the outside was pure logic on the inside. A machine designed to keep moving, no matter how tough the job. Railroad procurement officers were quick to voice their disapproval when EMD's GP30 prototype made its first rounds. The sharp roofline, the bulging radiator housing, and the abrupt blocky profile did not fit the image railroads had spent years cultivating. At Southern Pacific, the reaction was swift and pointed. Letters to EMD's sales team questioned whether any engineer would want to claim credit for the design. Santa Fe's purchasing department, known for its pride in the railroad's signature streamliners, returned technical queries that read more like demands. Could the hood be lowered, the bulge softened, the lines made less severe? Rumors spread through industry circles that some buyers threatened to walk away from their orders unless EMD reconsidered the look of the new locomotive. Minutes from internal meetings at several large carriers show executives debating whether the GP30's appearance would undermine their public image. One procurement officer called the new model an industrial mistake in a memo circulated among his peers. The phrase stuck, appearing in trade publications and whispered on shop floors from Chicago to Los Angeles. Even as EMD's sales staff tried to focus attention on horsepower and reliability, the message from the railroads was clear: looks mattered. A few railroads paused their procurement processes altogether, waiting to see if EMD would blink and offer a more palatable version. Others, like Union Pacific, asked for modifications not to the bodywork, but to the cab itself, requesting extra space for crew comfort. The pressure mounted, but EMD held its ground. The GP30 would go out on the rails as designed, and the only way to prove its worth was to put it to the test. When the first GP30 demonstrators rolled out of LaGrange, skepticism followed them to every division point. EMD's test crew put the prototype to work on a series of high-profile assignments, hauling long freights over mountain grades, switching heavy cuts in congested yards, and running local turns that demanded constant stops and starts. On the Rio Grande, the GP30 powered trains through the Rockies, pulling tonnage that would have required lash-ups of older units. In the Midwest, it handled both mainline freights and switching duties with equal confidence, moving from yard to road and back again without missing a beat. Railroad managers watched the numbers. The new turbocharged engine kept horsepower steady on steep climbs, letting the GP30 maintain speed where earlier models bogged down. Crews noticed the difference too. The locomotive's sharper throttle response and improved visibility made long shifts less exhausting, while shop foremen praised the walk-in access panels that turned major repairs into routine maintenance. One Illinois Railway Museum mechanic later recalled, "We could change out a generator on the GP30 in half the time it took on a GP9. The real proof came in the order books. Union Pacific, after putting the demonstrator through its paces, placed a single order for 152 units, including 40 cabeless boosters, some fitted with steam generators for passenger service. Other railroads, once hesitant, followed suit as the GP30's versatility became impossible to ignore. Instead of keeping separate fleets for road and yard work, companies found one locomotive could do it all. The GP30 was not just a new model, it was a new way of thinking about how power, reliability, and efficiency could be combined on the rails. Order sheets began filling up faster than anyone at EMD had predicted. In just over 2 years, the GP30 racked up 948 sales across 28 railroads, a record for any EMD road switcher at the time. Union Pacific led the charge, placing a single order for 152 units, including 40 cabeless boosters and 8 with steam generators for passenger service. That one deal alone would have made the GP30 a commercial success, but it was only the start. Railroads that had hesitated or even criticized the design reversed course as the numbers came in. The GP30 was not just replacing older engines. It was allowing companies to shrink their fleets, cut operating costs, and standardize power across both freight and passenger divisions. Don Strack, who has tracked EMD builder records for decades, describes the period as a sales avalanche. Orders from Southern, Santa Fe, Baltimore, and Ohio, and others poured in, each batch rolling out of LaGrange with the same boxy lines and unmistakable roofline. By the end of 1963, the GP30 had become not just accepted, but essential. A machine that proved performance could outshine tradition in the railroad business. By the middle of the 1960s, the boxy lines and functional features once ridiculed on the GP30 had spread across the entire locomotive industry. Alco's Century Series, starting with the C424 in 1963, wore squared-off hoods and blunt noses that looked more at home in a machine shop than on a parade float. GE, whose own U25B had helped spark the horsepower race, quickly adopted similar slab-sided bodies and high-mounted radiators in its Universal Series. Even Baldwin, before leaving the locomotive market, introduced models like the AS616 with pronounced angles and utilitarian details. These were not mere coincidences or half-hearted imitations. Every major manufacturer began releasing catalogs filled with engines that traced their visual lineage straight back to the GP30's controversial silhouette. The stepped cab, the prominent radiator blister, and the emphasis on easy maintenance became industry shorthand for modernity. By 1965, the old obsession with streamlining had faded into nostalgia. The GP30's once mocked profile had become the template for the next generation of road switchers, setting the standard for everything that followed. Today, the DNA of that so-called ugly locomotive can be spotted in nearly every freight engine crossing the continent. Every modern freight train rolling across North America today owes its shape and its efficiency to a design once dismissed as too ugly to succeed. In a world still obsessed with appearances, the GP30's legacy is a reminder. Progress rarely looks like we expect. Sometimes the future arrives in a form we are not ready to recognize. What innovations are we overlooking right now? Share your thoughts in the comments.